Hi, my name is Gabe Rueda, and welcome to my first lab presentation. The purpose of this lab is to model the motion of a marker rolling on tracker and compare the actual data and the modeled data. The data is modeled in GlowScript from initial velocity and position, and the actual data is taken from tracker. The theoretical model should be similar to the actual data because the marker rolls with little friction. You can see the fundamental principles on the right-hand side with the position, update, and velocity equations. The data here is two different sets. One is from the tracker data, and one is a model from GlowScript that uses the tracker data in the initial velocity and models what it would theoretically be. Tracker was used to model the observed data by taking a video of the marker rolling, calibrating the distance with a meter stick, and organizing the axes to follow the path of the marker. And then there's a track function that you can use to model the points in which they are at each frame. And this marker rolls along the x-axis in a positive direction so that it can have a positive motion in the data. The velocity is then taken from two of the starting frames, and that is considered the initial velocity, which then can be used in GlowScript to model this motion. And the GlowScript, as you can see here, is set to an initial velocity of 0.476, which is the difference in the distance between the two frames divided by the delta t, which is 0.01, and so it's 0.476 as the initial velocity here. And then the velocity in the model on GlowScript is considered constant and not changing because there's no other forces involved. There's no forces at all involved in the model on GlowScript, and so it's just a constant velocity and no net force acting on the marker motion. The observed data from the tracker model shows the actual change in position and is influenced by the force of gravity and normal force from the ground, but the two of them cancel and equal zero. The force of error, resistance, and friction also play a role in the observed motion. However, they're considered so small that normally they would be considered negligible, but the discrepancy between the observed and model data showed a marginal effect of these forces, and that's why when you see the graph, there's a slight downward curve in the observed position compared to the theoretical. The theoretical position data was calculated with the equation r equals r0 plus v delta t, r being the position theoretical, and v delta t was found from the initial velocity between the first two frames of the observed data, where x is close to 0 and delta t is very small in order to get an accurate initial velocity. Potential error from the experiment could have come from imperfection associated with manually tracking the marker frame by frame within tracker, but even then that error would be marginal. The axes would have been flipped, the data would have been negative, and the graph would have been flipped upside down, showing a negative velocity because it's going in the opposite direction. This lab is demonstrating the motion of a marker with very little friction and air resistance, and the difference between the observed and theoretical motion